Hi, and welcome to this video on the second application of closures. So here we're going to start with a very simple closure that's essentially going to be a counter. So we'll want to be able to provide an initial value, and then this closure will just increment that value by 1 every time. So let's go ahead and create that. So let's create counter, and we want to pass in an initial value. Now we want the initial value to be defined when we create this incrementer. So it's going to be a variable, a parameter of counter, and it's going to be a local variable of counter, therefore. And we don't have anything else, and we're going to create our inner function, inc, which is going to be our incrementer, and we'll allow also specifying what the increment should be, and we'll default it to 1. And if we want, we can even add a default of 0 for the initial value. And what are we going to do here? We're going to set our initial value. So now our initial value really is our current value, but it's this initial value. And we're going to increment it by increment. And then we're going to return initial value. And then we have to return our closure. So you'll notice that inc is a closure because it's referencing initial value. It's saying initial value plus or equals increment. So initial value is the initial value from counter. So hopefully again you'll realize that there's a problem here. We're assigning something to initial value. When Python sees that, it says, initial value is a local variable therefore. But in this case it's not. We want it to be the non-local variable that's in the external, outer function. So we have to specify non-local initial value. Okay? So now everything should work just fine. And we can create a counter, let's say counter1, that's equal to, now we're going to call the counter function, and we'll just let it default to 0. So now we have that, and if we call counter1, we get 1, if we call counter1 again, we get 2, and so on. So this is a very simple closure that basically allows us to define a counter, and we can specify both the start value and the step value. If you think back to a few videos back, we did the same thing, but we used like 2 nested functions. And I'd mentioned at the time that there's actually an easier way of doing it. Well, this is a much easier way of doing it. But at the time, I wanted to show you nested closures. Here, we don't require nested closures. Okay, so now that we have that, let's expand this a little bit. And what I want to be able to do is I want to be able to maintain a count of how many times a function has been run. So I want to be able to do that in my programs. So let's see how we might do something like that. So I'm going to call it counter. So I'm not going to specify an initial value. That's always going to be 0, right? How many times is a function being called initially? 0 times. But what I do want to pass in is the function that I'm going to call. Okay, so I'm going to pass in the function. So this is a higher order function already, right? Because it's taking in a function as a parameter. And I'm going to set my count equal to 0. Okay. Then I'm going to call inner. I'm going to define inner. And inner is going to be a function that takes in an arbitrary number of positional parameters and an arbitrary number of keyword only parameters. Why am I doing that? Well, you'll see. First of all, let me make count non-local. I want to be able to increment count. So there we go. It's non-local. And then I can say count plus or equals 1, right? So I'm incrementing count by 1. Which count? Well, the count in the closure. And then next, I'm going to just print out, so we can see the message that has been called 1 times, okay? And we'll format, and what are we going to pass in? We're going to pass in the name of the function, so f done the name. And then we also want to pass in the count. So we'll say, this function has been called 1 times, or 2 times, or 3 times, however many times it is. And then what are we going to do? Well, we want the inner function to basically now execute that function, to call that function. So it's going to call the function, passing in whatever arguments we have in star args and star quargs. So it's going to basically take any positional and any keyword parameters and throw them back to the function. So this inner function is essentially going to kind of replace our function fn because it's going to call it for us. So we're not going to call fn directly, we're going to call it indirectly by using this inner function here. That's our closure. The only thing it does extra, apart from just running the function, is to keep track of how many times it's been called. So now we have to, of course, remember to return the closure. So there we go. So now we have that. And let's define a couple of functions. Let's say add AB, and that's going to return A plus B, and then maybe mult A comma B, and it will return A times B. All right, so we have these two functions, addition and multiplication. So now what we can do? Well, we can say counter add. So this is a function that we're going to get by calling counter. So we're going to call counter, and we're going to pass it the add function. You'll notice we're not passing the arguments of add. We're just passing add because that's all that we need for counter. We will pass in the arguments to add when we call the closure, because the closure then will capture these arguments and then pass them along to the original function, which in this case now is going to be add. So now we have our closure, right? This is just a closure. You can see it this way, right? And we have two things in the closure. What are they? Well, we have fn and cnt, right? We have both of these things that are part of the closure because they're local variables to counter, but they're being referenced inside inner. So we can look at counter add, code, free vars, and you can see that the free variables are cnt and fn as expected. So now we can call it. We can say counter add. Now, how do we call it? Counter add is what? It's the inner function that will do some things and then call fn. So we need to pass it the arguments that we want to provide to add, just as if we had called add directly. So let's say 10 and 20. And as you can see, we get our result of 30. That's what comes back from this counter.add, right? So if you want to make it stand out even more, when you call it, it's been called now 2 times. Yeah, we called counter add 2 times. That's what it's doing. It's counting how many times we're calling the closure. And this closure has been called 2 times. And then the result is the result of adding 10 to 20. Now, of course, we could say counter mult equals counter mult. Right? So now we're going to track how many times we're calling this function over here. And we can say counter mult 2, 5, right? So that should, what am I doing? Sorry about that. Equals counter mult. Let's execute that. And then we can call counter mult, let's say with 2 and 5. And we get that mult has been called 1 times. And the result of that multiplication is 10. All right. So very simple extension to our original counter. We can now count the number of times a function has been called. So now let's take it a step further, and let's do this so that instead of just having the function defined inside and the name being returned in this print, I may want to store that value somewhere, not just have it printed out. So to do this, we're going to create a global variable that's essentially going to be a dictionary that contains the name of the function as its key and the number of times it's been called as a value. So let's go ahead and do that. And we're going to use, therefore, a global variable here. And we're going to start with an empty dictionary, right? So count is an empty dictionary. Now we have to define our counter function. And what is it going to take? Well, once more, it's going to take fn as an argument, right? We're going to pass it the function that we want to keep track of. Now here, we're going to say count equals 0, just as before. And our inner function is going to be the same. It's going to be star args, star quals. So it's going to basically capture the parameters, the arguments needed to call the function fn once it's done with whatever it needs to do. Well, what does it need to do? It needs to make a non-local count. And then it's going to increment count by 1, right? Because once we call the closure, we're going to be calling the function. So let's increment the count. Now, however, what do we want to do? Well, we want to store how many times this has been called in the counters object, in the counters dictionary. So we're going to say counters, and then the key is going to be the name of the function. And it's going to be equal to count. So now you'll notice that we have a few things going on here. count is a non-local variable, but counters hasn't been is not being assigned a value, because if you think about this, this is not an assignment to counters, it's an assignment to an element of counters. So yes, and which counters do we want? We want the global counters. So yeah, you could certainly write this, that's fine. That will work just fine, but we don't need to do this. So now we've assigned that, and we're going to return fn star args star quotes. So basically whatever we pass in will pass back to the function fn, call it, and grab the return value, and then return that from our closure. And then of course we need to return the closure itself. So now we have something that's a little bit more general, right? So now we could do something like this. We could say counted add equals counter add, and counted mult equals counter mult. Okay, so now we've got these two functions, counter add, or counted add, and let's call it counted mult, which have been run through counter. So we've got a closure back, two different closures of course, but those two different closures are still talking essentially to the same global variable. So now we can call counted add 1020, we can say counted add 2030, right? We get the value back that we would expect from the add function, but now we can look at the counters collection, and we can see that we have add was called 2 times. If we now call counted mult, let's say 2 and 5, we get the value back 10, and then counters, the global counters, has now this function mult, okay? All right, so that works, and that does kind of what we wanted to do. The only thing here is that I'm relying, this function here, counter, right, and the closure inner relies on the fact that there is a global variable called counters. So instead of doing that, because I don't want to have to, always remember and say, well, what should the name of the dictionary be? Because essentially that's what I've done. I've hard-coded the name of the dictionary inside this closure, right? So this closure, this is a global variable. I still want it to be potentially a global variable, but I don't want to always have to remember that I have to define counters first. So let's go ahead and modify this slightly. Now we're going to basically pass in the dictionary. So we're going to pass in the counters dictionary, and oops. So now notice what happens. Yes, we still have this counters that's a global variable, right, in the global scope. But now this counters that's over here is going to refer to which one? Well, Python's going to look at this, and it's going to look in the enclosing scope first. And it finds it as a local variable. So it's going to think, okay, counters is a non-local variable. And again, for the same reason we didn't have to specify global counters, we don't have to specify non-local counters, since we're not modifying what counters is, we're just modifying the contents of counters, just like when we modified the contents of a list. Okay. So now we can call it this way. We can say, let's say C equals a new dictionary object, and now I can say counted add equals counter add and C, right? And then we can say counted mult equals counter, if I can type, of mult and C. Okay, so now we have these two again functions, and we can call them just as before, counted add 10. Now before I do that, let me show you what the counters global variable contains, right? It has that. Now I'm going to call counted add 1020. I'm going to call counted mult 2, 5, and we'll call it again counted mult 3, 6. Okay. Now, if we look at the global counters, it's still the same. Add is 2, mult is 1. But if we look at C, which is the variable we used, you can see that add is 1 and mult is 2, because, yeah, we called add once and multiply twice. All right. So you can see how we were able to essentially modify what, mult did. We still retained the multiplication, we still retain the result of multiplying or adding these two values, but we now added some extra functionality using a closure, which is counting how many times they've been called. And you could do this with other things as well, like timing a function, for example. Now, as one last example of using count for these functions, let's go ahead and write a factorial function. So let's go ahead and write factorial n. So it's going to calculate the factorial. Now I'm not going to use recursion. Instead, I'm just going to do this using a loop. So for I in range, and we'll start at 2 and end at n, so we need to go to n plus 1, and we'll say the product is equal to the product times I. And then we'll return product. Okay? So this will calculate the factorial, right? We can calculate the factorial of 3, we get 6, the factorial of 5, right? We get 120, and so on. We can say counted fact equals counted or counter of factorial. And of course, we need to pass in the that dictionary C. Okay. So now we can say counted fact 5, right? And we get 120 back. And of course, if we look at C, we now see that fact was called once. But what I want to show here is that we don't have to rename this to counted fact. And instead of assigning it to counted fact, I'm going to assign it to the same name. And we need C. Hopefully I'll keep remembering that one. Okay, so fact now is no longer this function over here, right? If we look at fact now, it is indeed a closure, right? And so we have three things in the closure. What do we have? Well, we have the integer, which is the count. We have the dictionary object, which is that C that we passed in. And we have the function object, which is the function that we passed in, right? Located in 3 different cells. So as you can see, fact now works just as before. Remember, I could call fact 3. Well, now I can do that, and I can call fact 5, and so on. The only difference is that there's something extra going on. If I look at C, you can see that it's been called a few more times, right? Let's call fact 10, and let's look at C, and fact is now 3. And of course, I can do the same thing with add. I can say add equals counter add, comma C, and I can say mult equals counter mult, comma C. And I can still call add just as before. So now, right, I don't have to change the function name. It looks the same, but it's not quite the same function. It's been modified to add some extra stuff, and yet I can still call the function as if I was using the original function, right? My original factorial function was this one, but I've essentially modified that function. So we added an extra bit, right? Our original function was factorial or add or mult. We still are able to call factorial or add or mult. In fact, we call it using the same label, but that label now has changed what it really is. Before, it was the original add, mult, and fact functions. Now, it's the closure. And the closure basically still executes the original function, but does some extra bit. And that leads us directly into our next video, which is going to be on decorators. So thanks for watching, and I'll see you in a bit.